Let's look at example 3. Example 3 says that f of x is equal to 3x if x is less than 0, and that f of x is equal to the cubed root of x plus 1 if x is greater than or equal to 0. So again, step 1, identify the change of behavior value. Well, it looks like my change of behavior value is 0. So then I have to figure out what happens for my top equation at 0. Well, when I plug in 0 at the top equation, 3 times 0 is 0, the y value I get is 0. Then again, plug it into the bottom equation. Well, the cubed root of 0 plus 1, the cubed root of 0 is 0, and 0 plus 1 is 1. So in the bottom equation, when I plug in 0, my output or my y value is 1. Determine whether these should be open or closed. Well, this does not have an or equal to, so it's an open circle. This has an or equal to bar, so it's a closed circle. So let's go ahead and graph both of those. So I have the point 0, 0 that's open, and I have the point 0, 1 which is closed. Next, let's start with the top function. Figure out what it is and graph it, and then get rid of it where it doesn't belong. So my top function is f of x is equal to 3x. Well, what kind of thing is this? Well, this is just a line, so you can think of it as y equals 3x. So let's identify my slope and my y-intercept for this particular line. Well, the slope, again, is always going to be the number in front of x, happens to be 3, so it'll be 3 over 1. My y-intercept is always the number here I'm adding. Well, there's no number that I'm adding or subtracting, so I can say my y-intercept is 0. So let's graph this line knowing this information. Of course, the slope of 3 over 1 means up 3 and right 1. So from my y-intercept of 0, 0, I need to go up 1, 2, 3 units and then over 1 unit. So let me go ahead and try to graph this. Alright, so there's the graph of f of x equals 3x. But again, where do I exist? It says I can only exist where the x-axis is less than 0, right? Or the x values. Well, this is 0 on the x-axis. Here's negative 1, negative 2, negative 3, so on. Here's 1, 2, 3, so on. So where are the numbers less than 0? They are less than 0 over here to the right. So I have to get rid of this line up here to the right. So again, they were less than over here to the left. So I had to get rid of the line to the right. Let's figure out what the bottom equation is. The bottom equation is f of x is equal to the cubed root of x plus 1. Well, this is one of those basic shape transformation things that we learned before, so I have to figure out what this is. Well, the cubed root of x looked like that stretched out s, and its key points went in opposite direction. Let's find our transformation. Do I have a horizontal shift? Nope, there's no number under here under the radical with x. Do I have a vertical shift? Yes, I do. My vertical shift is up 1. So that means that my vertex is going to be 0, 1. Do I have a compression stretch? Is there a number I'm multiplying out here? Nope, there isn't, so I can just write 1. So using this information, let's go ahead and graph f of x equals the cubed root of x plus 1. Alright, so again, first thing is I plot my vertex. Well, my vertex is on here, so then I need to use the compression stretch to find my key points. Now remember, for that one, I need to go up and right. So from here, I go up and right. And then I have to do the complete opposite thing, which is from that vertex again, go down and left. Right, make this look like a stretched out S. But where does it exist? Because we're not done. Where do I exist? I only exist at values that are greater than or equal to 0. Well, is that to the left of 0 or to the right of 0? Well, those are to the right of 0, so everything over here to the left, I have to erase. Again, we got to know that to the left, I'm this line down here. So to the left, I'm this, and to the right, I'm the other line. Last example that we have, example 4. Same things, I need to graph this piecewise defined function. But this one has 3 different equations, and it looks like it's got a lot of mess going on in the middle. That's okay. So let's just kind of figure out what's going on for each one of these. So what's the change of behavior value for the top one? 0, right? It behaves one way at 0. So let's find out what the value is when I plug in a 0. Well, if I plug in a 0 to the top function, I'm going to get 0 plus 5, or 5. So I have the point 0, 5. Well, the middle function only exists between 0 and 4, so it actually has two change of behavior values, one at 0 and one at 4, because it behaves differently to the left of 0, and it's going to behave differently to the right of 0. So I need to figure out what happens to this function at both spots. So let's see, if I plug in a 0, well, that's a constant function, right? There's no place to put in a 0. So we know that when I put in a 0, I'm going to get 5. When I put in a 4, I'm going to get 5. Again, that's just a constant function. That's just a horizontal line. So no matter what your x is, you're always going to be 5 as an output. To the bottom. All right, the bottom, well, its change of behavior value, the only thing that matters for it is 4. Why 4? Because, again, it's just existing to the right of 4, so I don't even know what happens at 0. It doesn't exist at 0. It doesn't matter to me at all. So the bottom one, its change of behavior value is going to be 4. So plug in 4, figure out what you get. So I get the square root of 4 minus 4 plus 1. Well, the square root of 4 minus 4 is the square root of 0 plus 1. Square root of 0 is 0, and 0 plus 1 is 1. So when x is 4 in the bottom function, y is 1. All right, let's determine if these should be open and closed and plot them. So this top one is just a less than, so I know it's going to be open. So I'm going to go ahead and plot 0, 5 right here, and it should have been an open circle. So 1, 2, 3, 4, 5 with an open circle. All right, then I'm going to look at my purple. Well, I have 0, 5 again, but it's got the or equal to with that 0, so that's going to be closed. Remember, if you got the same point, it's open and closed, just make it closed. Closed trumps open, right? What about the bottom one? I got the point 4, 5. There's no or equal to there, so that's going to be open. So it's going to be an open circle. Finally, I have the last point, 4, 1, open or closed. Again, it's got an or equal to, so this guy's got to be closed. So I have the point 4, 1, and we are closed right there. I have all my dots on. Now it's time to graph these lines. Again, let's look at the top. Well, what's the top equation? The top one is f of x is equal to negative 2x plus 5. Well, what is this? Again, this is a line, so think of it as y equals negative 2x plus 5. What's the slope of my line? M is negative 2 over 1. What's the y-intercept? It's 5. So let's graph it using slope and y-intercept. So I start with going to my y-intercept of 5, this dot. My slope tells me I need to go down 2 and then right 1. So from this point, I'm going to go down 1, 2 units and then right 1. All right, so there we are. We made our line. Okay, but I'm not done. Where do I exist? I only exist to the left of 0. So again, here's 0 on the x-axis. Here's negative 1, negative 2, here's 1 and 2. Well, where are the numbers that are less than 0? Well, those numbers are over here to the left, so I have to erase this blue line everywhere on the right-hand side, because it only exists to the left of 0. So it's only existing over here. Great. What about the next one? Well, the middle one here is f of x is equal to 5. Again, this is my middle function. Well, f of x is equal to 5. That's just a horizontal line at y equal 5. So if I draw a horizontal line at 5, I'm going to look like this. But is that right? No, because where does it exist? It only exists between the x values of 0 and 4. So here's 0 on my x-axis, 1, 2, 3, 4. So I only exist in between those two numbers. I don't exist to the left of 0. That's the blue line. So I need to erase the purple there because it doesn't exist there. And I don't exist to the right of 4 because that's going to end up being my red line. So the only place that I exist for the middle function is between 0 and 4. So I can only draw that horizontal line there between 0 and 4. All right, let's look at the bottom function and then we're all done. Well, the bottom function is my f of x is equal to the square root of x minus 4 plus 1. Well, that's one of those basic shapes that I need to have memorized. Square root function, what did that look like? That's half of a sideways parabola, and it's got one key point. Well, let's figure out what my horizontal shift is if I have one. Horizontal shift, is there a number here with x? Yeah, there is a number here with x. It's -4. Remember, your horizontal shifts are always opposite your intuition, so a -4 means that you're going right 4. So I'm going right 4. Do I have a vertical shift? I do. I have a +1. Well, that tells me I need to go up 1. So the new vertex for this guy is going to be 4, 1. Well, do I have a compression stretch? Is there a number that I'm multiplying this function by? Is there a number out here? There isn't, so I can just write 1. And again, that's going to help me find my key point. So the first thing I needed to do was plot my vertex. So my vertex was 4, 1. It's already plotted. Great. Then I need to find my key point. Well, remember, that's only one key point, and since it's a 1, it's going to go in the same direction. It's going to go up 1, and then we're always to the right 1 for these. So from this point, I need to go up 1 and 1 over here to the right, and then draw it in. So this is the graph of f of x is equal to the square root of x minus 4 plus 1. Now, do I need to erase anything here? Well, this one only exists to the right of 4, or where x is greater than or equal to 4, but the way that the square root function is anyway, that's all I could have drawn anyway. So I have nothing to erase here, because if you look, this red line's only going to the right of 4 on the x-axis. So these blue, purple, and red lines make up this piecewise defined function. That's it for this section on piecewise defined functions.